Hey guys, what is up today? I think we're ready to go here. What's up, Marky? Yeah, I have it put away, don't worry. Zapal, what's up, guys? Uh, Nicholas, how's it going? As you can see from the title of the stream today, we're finally going to get around to testing the conductive graphite. The conductive graphite from Proto-Pasta. I've had this for a few weeks now, and I've wanted to test it. And I finally got around to throw in like a few like simple files together that we're going to test. What's printing now, it's a little hard to see because the filament's black. Like you can kind of see it there. Kind of, sort of, not really. There's just some basic rods in different thicknesses that are finishing up here. And then once that's finished, this is the little test print I threw together to try a few different things out. And basically we have a few different traces. And I think these are all a little oversized because I want to be sure that we have something that actually works. But I've got 3 sets of different sized traces here. And we're just going to use some alligator clips and a little bit of battery power. And see if we can get some really, really, really basic, like elementary school level circuits to work. And you see with this, we're using 2 different processes. One is for the PLA, which is just basic like PLA, some basic PLA action. And then the ones for the graphite filament, we're actually going to print a little bit slower. We're going to print at 100% infill, and we're going to print at the high end of the recommended temperature range for this filament to try to get the best like interlayer and interparticle contact, so we hopefully get as much conductivity as this stuff has to offer. So that's what we're going to be doing today. The print back there is going to be finishing up in a few minutes here, and then hopefully that little circuit board works out because it has a color change. I used the Prusa color change little web interface. Can you solder to the EC filament? I don't know. We're going to try today. I have a feeling it's just going to melt. But we're going to try. We're going to see if we can get solder to stick to it at all. Like I said, I wouldn't be surprised if it doesn't. I wouldn't be surprised if we just like melt it and we can't get solder to stick at all. But we're going to give it a try. But otherwise, I have some really tiny drill bits, and we're gonna make some really tiny holes in there to stick our LEDs and stuff in. But let me catch up on chat here for a second. my chat thing doesn't want to work. Hey, what's up, Josh, Bob, Smudo? I'm saying that right, Matthew. What's up, Joey? Can use I think Joey already answered. Was it Joey that answered that? Bob, can you use blue painter's tape with the heated bed? Yeah, there's no problems. In general, unless you're using a filament that you end up getting more adhesion than you'd like, there really isn't an advantage. The few times I've used blue painter's tape was actually just to get like that kind of texture on the bottom of the print. That has been one of the most useful things I've used blue painter's tape for, with PLA at least. But with other filaments, yeah, if I'm trying to think, like PETG, I think you end up getting a little more adhesion on the PEI sheet. I could be wrong. There's probably someone in chat that has more experience with it than me, but I like using the blue painter's tape because sometimes you don't want that perfectly smooth bottom layer on your prints, and the blue painter's tape gives you like a tiny little bit of texture. Yeah, there's Joseph. Joseph in chat, I think, has printed quite a bit of PETG. And if I'm not mistaken, with like the PEI sheet, you end up getting a little more adhesion than you'd like. And that's a good way to kind of mitigate that. Matthew said, Nilla, you should get in one of our Friday night streams. What are you speaking of, sir? Because especially if it has to do with 3D printing, I'm all for like being part of the community. Why can't I scroll, YouTube? Oh, there we go. Okay, I couldn't scroll my YouTube chat. Be cool to print custom buttons. There's, excuse me. Of course, my throat starts giving me problems as soon as I start. It was fine all morning. There aren't really a lot of people that have done much with the conductive filament. I was looking around for some cool little projects and stuff, but there's a shocking, complete lack of prints that are made for the conductive filament. For some reason, PETG. Yeah, it's crazy how like people's experiences vary. But I'm gonna finish rounding up the few little things we need. I need to find a couple LEDs, but everything should be right here. There's an ultraviolet. I don't know if that shows up on camera here. There's an ultraviolet LED light I made as a bill validator. Looks like the batteries are going dead. Here's a few. I don't know what we have in here. And batteries. Oh, they're over here. I knew I got them. So I think I'm going to have more voltage than is required for some of these LEDs. I guess it won't hurt. We shouldn't blow them out instantly, so they should be all right. Can't see an ultraviolet, right? Yeah, I guess with those LEDs, there's just like some of the light is in the visible spectrum, even though most of it's ultraviolet. Matthew said it was a buzz, Juicy Moose, Sparky Face. I think I caught the tail end of one of those the other day. Is that what you're talking about? I think I got in like right as I saw, what's her name, Heather? Heather had posted something on Twitter. So I went in, like I was getting ready to go to bed and I saw that and I was like, well, hell, I'll check it out. And I think I got in there right as everyone was saying their goodbyes. Insert some copper wires. Yeah, but that's like, I'm sure that works really well, but that's kind of like cheating. You could almost do that with just PLA. Which would kind of be cool, actually. Yeah, you could put some really small voids in PLA prints and just press some like some of that coated magnet wire or something in there, and you could have integrated circuits like that. That would actually be kind of cool to experiment with. Yeah, but Matthew, I'd be down for that. Fridays at 10 p.m. That's like perfect. That's right when my wife goes to bed. I'm a free man after 10 o'clock most days. But it looks like the last one of these is finishing up. This, I don't know if you can really see that, but it looks like it's over extruding just a tiny little bit on the infill, which normally I would adjust the settings on, but I think I'm okay with it on this. I'm hoping that putting that in there kind of like slow and hot will improve our conductivity. Let's get some batteries out. Because I used to do a lot of stuff with electronics, and I always use these little, like, battery pack things. And I used to have a bunch for doing different voltages, but I can only find a 2, an 8, and I think that's it. Because I think generally you need around 5 volts for LEDs. I don't know what these happen to be. They're just a couple... They're used, actually. But we'll do a quick test here to make sure they work. So if we don't have a success, we're not blaming it on the filament when we have a dead LED. Alright, let's give this a try here. Oh, well, that'll never work. Okay. I kind of felt bad. I sort of violently ripped this out of a project, and it pulled part of the breadboard off of it. But I was in a hurry. All right, surely one of these LEDs works. Yeah, this one looks like it's teal. Maybe we did just burn it out. I think we did. It smells like we've released the magic smoke from the component. So we might need a resistor. We'll have to look up the cheat sheet. Because I would imagine these are either 3 or 5 volt LEDs. Yeah, like Nicholas said, these are probably... I do have some 5 volts, but these are most likely 3 volt. Let's look up the... This is not what I planned on doing with myself on this stream. But let's look up one of those LED calculator cheat sheets. Because we're working with... what would that be? 8 AA's would be 3, 6, 12 volts. 12 volts, I'm guessing. So we're gonna need a couple resistors in here. Diode forward voltage. We'll say 3 volts. Diode forward current milliamps. I don't know. What value should we stick in there? I wish it's been so long. We'll, again, just going purely from memory, we'll try 20. Oh, yeah, that's, okay. So 20 was a good guess. All right, so I didn't forget everything. So it looks like we're looking for about 470 ohms at half a watt. That shouldn't matter. We won't burn out a quarter watt resistor. I think that's all I have on hand. So what are we looking for? Yellow, violet, brown. I can do that. Alright. Man, it's been a while since I've had to dig through any of this crap. Sorry. Thanks for bearing with me, everybody. Yellow, violet, brown. There we go. I'll just pull the little pack of them out. That's why it's nice to have all that stuff on hand. And I guess we can go ahead and solder that onto the LED to save us frustration later. So I got my little Heiko soldering station here we're going to use. And it doesn't really hurt for us to get this ready because we wanted to try and actually solder to the filament if we can, which I think is a bit of a pipe dream, but I guess we'll see. That's what I wanted to print these little rods out with, so we don't actually like destroy our print that we're going to be working with. All right, this thing heats up extremely fast, so this will only take a moment. So get one of these guys out. Trim it so we don't have a mile of leg sticking off of this thing. That's what I love about the soldering station. That's to temperature already. That's already at 600 degrees. And I remember the days of using my little $5 Radio Shack soldering iron. How times have changed. So let's get a little bit of solder on each of these leads. Tiny little bit of solder on the tip. I should be using my gator clamp things, but I should be able to hold this with only minor contact burns. Ouch. It's only 600 degrees, right? 650? That's not too bad. Yeah, that's true. The resistance of the filament might actually be enough. I think this filament has fairly high resistance. That's why I wanted to print these rods out to do some tests. So luckily I have some other LEDs laying here. So it could be the case that we actually don't need a resistor in this because the filament itself is going to have so much resistance. Does Radio Shack still exist? We had one in our town up until about 5 years ago, I think. About 5 years ago. And, like, I had such a love-hate relationship with Radio Shack because it was handy to be able to, like, go pick things up immediately whenever you'd need them, but their prices were ridiculous. Resistance is useless. It's futile. Futile. Come on now. Let's put a little bit more solder on here. There we go. That looks nice. All right, let's leave it. So hopefully we can now use this without immediately burning it out, which would be a plus. Because I smelled something funny as soon as like that one started glowing for a minute, and then something smelled funny. There we go. Oh, these are the ultraviolets. So I don't know if you can see that. There's like a blue haze around there. But yeah, this one works. I hope they're not all ultraviolet. They very well might be. Try them for a second here. This one looks different. Popped it. I popped it immediately. 12 volts, a little too much. In the trash can you go. Let me see if I can find a couple more LEDs that'll be easier to see. Also, the camera does pick that up. Okay. Okay. So that's cool. Yeah, rip. Sorry, LED. You were just beginning to love. So we've got our voltometer. I think we're ready. We're ready. Like, most of our lives are spent. Now we're just waiting on a print. Got our soldering station ready. Got some gator clips. Got some coffee. Where are we at here? I printed out a few different sizes. Like I said, it's a little tough to see there, but there's a... they're all square. They're dimensionally square, and then 50 centimeters long, or 50 millimeters long. We have a 1x1, a 3x3, I think a 7x7, and then a 10x10. I think I was going to print more, but I didn't want to be sitting here for an hour waiting on that print, because we're going to have to wait a little bit on the other print. Yeah. Oh, he's getting me out. Oh, he's going to use me. And I'm dead. Such is the life of an LED in Nilla's workshop. Oh, well. That's why you buy them in packs, right? Let me see. I can grab a couple more. I've got quite a few tubs. If you guys have ever seen those places that sell like bulk, I guess they're like seconds. They're like, they pull them off assembly lines whenever I guess they finish the job, and they still have like strips of stuff left. Old converted PC power supplies that I used to use for my power supplies because I was too cheap to buy one. This little terrifying thing. This was these are called flybacks out of monitors. If you ever seen videos of people trying to make like big arcs, this thing will throw with this battery pack, if you can believe it, with 12 volts. This thing will arc about 3 inches out of this flyback with this little. Oh, it was so bad. That's when I was younger. That's some rough solder work there. Little heat sink on the transistor, everything. It's not too bad, eh? For an idiot. It's a wonder I never killed myself. But yeah, we've got some LEDs in here. These ones look like they're a little beefier. They appear to be from like industrial control panels or something. Can this handle 12 volts? Oh, this is a 250 volt. Holy hell. This one scoffs at our 12 volts. So maybe I don't have anything appropriate. I was thinking I'd have some like normal LEDs in here. I do have a couple of these little indicator strip things. How do they work? Same deal. Blew it instantly. Yes. All right, so maybe 12. 12's a little much. So I guess it is the case that this little 3-volt one is actually perfect. Maybe we should be using that. What did I do with my batteries? It's like an LED holocaust over here. But there's so many cool components in these big like lots that you get. There were so many cool projects I did for no other reason than that I would get like unique parts and be like, I gotta use that. Like crystals, there's a lot of cool things you can do with oscillator crystals. And we're done. Let's see if we can get one of these to work without destroying it. Heyo! Why can't we get the other one lit up? Oh, there we go. That's kind of cool. See, like that. 2 little LEDs. And they play nice with 3 volts. Okay, that's enough of that. So let's get these things off and get our other print started with our PLA base. We're gonna have to give that a minute to cool. But to catch anyone up that is just joining us, the next print we're going to start is this actual little circuit that I laid out that's really, really simple. And you can see we're using two different processes in Simplify. The base is just going to be regular PLA, and we're going to print it not super fast, but relatively fast. And then all these traces, I forget the actual diameters of them, or the actual like external dimensions. I think we have like a 5x5, a 4x4, and a 3x3, if I remember correctly. So they're not tiny. So hopefully they're enough to give us like some reasonable levels of conductivity. But that's what we're going to start now, and you can see there's going to be a color change. I use the web utility to cue that in the G code. So it's going to print us like a nice colorful. We'll use something bright, like maybe the green I have here. A nice bright PLA base, and then we're going to use this conductive graphite for the actual traces. And you can see this is about as simple. I mean, I guess it still technically is a circuit, but we're just basically using these as like some wire replacements in our tiny little circuits. So that's what we're going to be starting as soon as this cools a minute, so I can get these off without bending them. They're still a little soft. This filament seems to print really nice. It extrudes like really smoothly, which I guess being graphite, the powder is probably super, super fine, like compared to some of the metal fills and stuff. A guitar pedal PCB, that'd be kind of cool. I've seen people, like I mentioned earlier, there doesn't seem to be too many projects that people have made for this stuff. Because it kind of makes me want to design a print or like a little, what would you consider that? Like a modular print of some kind for people to play with this filament, because there just aren't many. There's a couple little LED flashlights, but some of them aren't, I don't think, designed all that well. I think they're going to be a little tough to print. And then one of the cooler ones I saw, you kind of need to have a dual extruder. They claim you can print it with a single extruder, but any of you guys are printing with two colors, you know that like we can only print different colors on different layers. So like one layer has to be completely one type of filament, and the ones that I saw, they were saying you could do it with a single extruder, but then there was more than one type of material on a couple of the layers, and I don't think that would really work out. Do you need to use a hardened nozzle with the... I don't know. I don't take this as like gospel, but I would imagine not, because graphite's really like super soft. So I would think if anything, like if you do have, some friction between the filament and the nozzle, it's probably going to have like a lubricating effect on it more than like an abrasive effect. I could be wrong. We should probably check Proto-Pasta's site, but yeah, like Warboy said, I can't imagine powdered lubricant would need a hardened nozzle. Exactly. So let's get these off of here. Wow. We had good adhesion with that. Holy crap. Okay, there was absolutely a little bit of over extrusion, especially on the top layers. But I think I set my infill overlap like really, really high. I think I set it up to like 30% or something like that. Just to make sure we got, like, this is a solid piece. And this kind of reminds me of some of the metal infill, like the bronze fill and the polishable stainless. Like, this is very dense. Not that graphite's very heavy, but this, you can tell this is like a very dense filament. This weighs more than I'm pretty sure like a block of PLA that was 10 by 10 by 50 would weigh. It's got a little bit of mass to it. So we're going to change colors. We'll preheat for PLA. We'll get our green in here, get this print started, and then start messing with these little blocks here. We'll try soldering to them. We'll probably check and see what the resistance of these pieces are. Again, I wouldn't be surprised if it's super, super high. Because all I've really seen these used for are really, really basic circuits like driving LEDs and stuff. But it would be cool to print a guitar pedal or something. I've got a couple guitar pedals from when I played, and some of them, like I have some of the old Ibanez Tube Screamers, and I've been meaning to sell them because if you mod them, they bring like a fair amount of money. Josh Smith says use 9-volt. Yeah, I do have some 9-volts back there. They're probably dead. 9-volts are terrible for kind of just dying. The conductive ink pens. Yeah, there's actually a fair amount of conductive filaments on the market now. Like, I've seen some conductive ABS. There's some conductive PETG. So I would imagine they have put them in the freezer. My wife's mom does that with all batteries. And again, unless I'm mistaken, I don't think there's any advantage to doing that. I guess the idea is that it slows the chemical reaction down. I honestly don't know. But we make fun of her mom every time she gets a battery out of the freezer. But, okay, color. Change our color here. What do you guys think? We're going to use something bright. I have purple, green, I have the orange, and I guess that's it for, like, obnoxiously bright colors. We have gray, but that's not bright. I also have the natural that doesn't have any color in it. I guess that would be contrasty. Any preference? Anybody? 10 seconds? 10 seconds, I'm going with the green. Going with the green. So we have 2 purples and 2 greens. We need a tiebreaker here. Somebody? Green. Okay, green it is. All right. So we'll get this print underway and then destroy these pieces, I would assume. Damn you, Bob. Pink. I don't... This is... like they call it purple, but it is. This is kind of like on cam. It looks like that too. This is kind of like in between pink and purple. Because I think they do need a pink. It's funny, when I first started printing, I would see those obnoxiously bright colors and think like, man, why the hell would you ever need that? Why would you just print stuff in gray and things that are more subdued? And now that I have them, I use them for all kinds of stuff because it makes prints look cooler. Fire extinguisher? No, the color is not clear. Wow, that stuff seems to linger in the extruder. I don't know if you can see that. I've run a moderate amount through already, and it's still black. Yeah, Joey, it's gonna take. You can tell it's gonna take a bit to clear this. It is still jet black. I've probably extruded another. I would say, like, I just queued up 100 millimeters there, and it's still pretty much black. That's kind of crazy. There's another 50 millimeters. Yeah, we probably should have done the atomic pull. Nilla, do you live in sweats? I do not. I generally, if you look like at most of my old streams, I almost never wear, like, these are basically my night pants. Holy shit, that is still like jet black. Yeah, that is still like completely jet black. Plus, what's wrong with living in sweats? I couldn't even finish that sentence without feeling ashamed of myself. Don't live in sweats. Hey, we're turning the corner. It's like a forest green now. We could do an atomic pull, but I think at this point we just need to commit. I think that definitely confirms the idea that the particulate is extremely fine. And we probably have a very well lubricated nozzle now. At this point, we'll let it go because it should be clear. I guess we don't want any like inter-trace conductivity. I think we're getting there. Well, yeah, pretty much Crazy Joe. The little waist tower there looks kind of cool. It's like a super subtle change. Weigh that blob. It's got to have a little bit of weight to it. I love how it kind of lays down like that. It does really look cool. All right, I think we're good. I don't know how much I turned the damn knob, but we'll let it stop. But it is so cool how it lays down like that. Somebody like we're going to do that next or maybe we'll do that Thursday. We need to try and do some manual prints. Like 100% manually extrude everything with the move axis controls and see if we can make a print that's something. That's like you could totally make Christmas trees or something like this. That's like really cool. Hey, what's up, Sparky? Nice nice vase. Yeah, we just did a manual vase mode basically. Let me clean that up. This is a cool little print though. I'd say that weighs 5 or 6 grams. Just to clear that graphite. That's kind of crazy. $2 grams. We spent 2 grams of filament to clear the nozzle. All right, let me clean this up. We'll set that over there. This is definitely a piece I'm not throwing away. That's a cool little piece. Our little Christmas tree of shame. Okay, so we're clear now. Okay, we are underway. Let's destroy our test pieces here. So, again, always like pressed for space. I am going to, this week I'm ordering some light boxes, which should help with the shadows when we do some of this stuff. Does that look all right? And let's adjust the zoom here, or the focus, rather. Does it look about right? Does that look acceptable? If we're working right about here? Yeah, it looks all right. Okay. So again, we have our cool little LEDs. I guess we're not using these. Oh, that's going to blow it. So we've got our LEDs. Our little signal lights. Cool. Okay. Let's start with the most basic things. I'll see if I can get this. See, we can see everything at once here. We're going to go to... Okay, so we're already on resistance. And we're going to see what kind of like resistance these pieces have. Let's start with the smallest one. This is the, obviously a very small piece. This is 1 centimeter by 1 centimeter, I think. No, that can't be a centimeter. I think it is, though. That's not a centimeter. Oh, 1 millimeter. Which, not surprisingly, it's not super dimensionally accurate. You see it was like over extruding a little bit. But anyway, so this is a 1 by 1. I'm pretty sure like a a 3x3, or approximately, a 5x5, and then a 10x10. Again, approximately. It was over extruding, so it's not super dimensionally accurate. So we'll start with this one. And see what kind of resistance levels it has. So this is looking like about 5.5 kiloohms. Somewhere in that range. And it's very sensitive to, I'm trying to pinch that as hard as I can. Yeah, you can see, like, this is not ideal conductive material. Let me see if I get my fingers out of the equation. I'm trying to oops. Try to really stab that in there. So going bigger definitely helps. So that looks like about a kiloohm. And then our biggest piece, predictably, should have the least resistance. See, this is what I was kind of curious of. It looks like there's not... you start to reach the limits of the material itself, because there with the 5x5, we were at, what? Right, I can't hold that still. We were at about a kiloohm. Somewhere in that region. It's so sensitive to everything, like just wiggling these. You can see like how inconsistent the material is. So what, about a kiloohm, and then it doesn't look like we gain a whole lot of conductivity by doubling in size at that point. Because this is slightly better. I don't know. This stuff, you can see this already, that this stuff is erratic as far as like its electrical performance. Like super erratic. Holy crap. So there we're at half a kiloohm, and for some reason from the other side, like, and I'm really stabbing these in there. So it looks like that bottom layer, the smooth side, gives us the best performance as far as conductivity. I guess because that layer lays down a little bit hotter and is smushed together a bit more than the top layer is. So that's what we're working with here. And we'll see if that's true on the other one. This is the kind of over extruded top layer. Again, we're at about 2.2. And then on the bottom layer, we're probably at like, what, 1.2, something like that again. Or even less, actually. Hell, half a kiloohm? How about the sides? Half a kiloohm. So it seems like the top layers actually perform pretty poorly. For whatever reason. Yeah, there's like notably more resistance on the top layer than the other sides. That is not something you generally see in a conductive material. But anyway, so we do conduct electricity. So hey-o. You could do the dummy test. I don't know if you can hear that. Like, this is just a continuity test. And it's not actually... There's not enough current to tell us that we have continuity, which is kind of weird. Even with the probes, like, all but touching. Okay, interesting. So let's do some tests. Let's first So we'll take our battery here. Let me zoom out a bit. We're going to take, we'll set this aside. We don't need that. We're going to take our 8-pack. So this is, what did we say, 12 volts? This is 12 volts DC. And we use our red clip on our positive lead. I assume that's our positive lead. Yeah. And yellow on the other one. And we're going to take one of the LEDs without a resistor. And see if we can get enough current because I think see, I'm such a noob anymore. I forget which way LEDs go. Okay, so we do have conductivity. So here is just the LED. Let me know if that's focused satisfactorily. Where's our focus at? Right about here. So there we just have this clip to the 5x5 where we have 12 volts into a 3 volt LED and it works. It's conducting and it's not blowing because we have approximately a kilo ohm. I forget which what resistance did we end up using for 12 volts into our 3 volt LED? I forget. I don't think I have that window open. Oh, I do. So we were at approximately 500 ohms. So yeah, this is actually we don't need a resistor with this because this is actually about twice the resistance that this LED actually requires to run with 12 volts. So I think this would safely run this LED for a significant period of time. So that's interesting. I don't know if I can get a gator clip on this big ass piece. I don't think I can. So this one should be a little bit brighter. That one makes the LED just a hair brighter on the underside, and then I would assume it's a little bit dimmer on this side. You can see it's like pretty inconsistent on this top layer here. So yeah, this actually, I'm kind of pleasantly surprised. It seems like this filament conducts enough that you could do quite a bit of stuff with it if you just design your projects around about what do we say, about a kilo ohm. So actually, well, while we're sitting here, let's test this small piece. I think this small piece had the highest level of resistance. Let's see if we still have enough current to work the LED. So it looks like we do. Touchy, touchy. So it looks like even if your traces are, what do we say, about 1 millimeter by 1 millimeter. I wish I would have done smaller ones. I guess the problem you run into is even this print, it's probably a little tough to see. Yeah, you can't. I can't show you. This is basically just 2 perimeters. There's a tiny little bit of gap in between the perimeters of this. I don't know if I can pull them apart. Yeah, I can actually. But there you can see, you guys have probably run into this with other stuff. This was so thin when compared to our extrusion width that it's really just two perimeters, which I guess is a good way. Oh, that's actually perfect. Because I was saying I wish I had made a thinner piece, and right here we have 2 thinner pieces. So we're just going to separate these. Awesome. That worked out perfect. Okay. Yeah, hell, that's like the thickness of some wire, almost. Because there we're looking at about 3/4 of a millimeter, about 0.75, 0.76. And let's see what kind of resistance this has. I'm sure it's going to slowly climb here. because these pieces are getting small. But I'll actually just lay it on the screen here and see if I can get it. You bastard. Oh, that's right. We're on continuity. I'm sorry. Yeah, we have significantly higher resistance there. That was at like 7 kiloohms. So I guess with small traces, it would become an issue in some of your projects. You'd have to have a really high supply voltage, and then these will probably get hot. Yeah, they were looking at what, like 10 was peaking at like 10 kiloohms. So again, you could design your projects around that. It wouldn't, I guess it wouldn't, you know, eliminate the possibility of using traces this small, but it quickly becomes impractical when you get too small. So now let's try the other thing we were kind of curious about here. Let me get a little wire lead. These are little breadboard leads. We grab a couple of these little white ones. They're just like pre-stripped wire that you use for like doing projects on breadboards and stuff. Resistance is futile. We need to keep a running tally of how many times that is said. See you, Sparky. Thanks for stopping by. Sorry I wasn't paying attention for chat or to chat. Just break some off the vase you made. No. No. Not breaking my nice vase. I printed a vase yesterday. Yeah, these things are so sweet. Like, I don't know what it is. These prints are like so satisfying to me. This is one of the ones that's fairly impractical. That's smaller than my thumb. About the size of my pinky. So you're not really going to put a whole lot of flowers in there. I guess you could put like a single flower in there. But these are so satisfying to print for whatever reason. I want to do one. This is at 100% for this file. And I want to do one that is the max height for the MK2, which I forget what it is exactly. I think it's around 200 millimeters. Somewhere in that region. I forget. Maybe it's 180. But yeah, these are so satisfying to print. I remember the first one was the one that came on the Prusa SD card, which this is a little more practical size. You can see I actually use a pair of these for my brush holders. But there's something so satisfying about them. I guess it's just like the consistency. And this one's even printed at 200 micron layer height, which is fairly high. And they just come out so consistent that you don't really notice the layers. There's a little bit of, I don't know if you can see it in there, every 10 millimeters or so. There's a line in the file that I noticed, but still, these are such great gifts to give to people. Like if you ever want to print something to give to people, to kind of make them think, oh damn, 3D printing is kind of cool. These are fantastic. Like even my 50 and 60-year-old family members, like I've given them some of these, and they're a great like introductory print for people to kind of get excited about 3D printing. Can it hold water? We can find out. I know the orange one doesn't. I actually don't have any water down here. We can try a little bit of alcohol. What's the worst that could happen? It seems to. I know with the The orange one, which I actually have here, the orange one I did test. I put some water in it, and I think this only has like 3 or 4 bottom layers, and it actually is not watertight. So I kind of knew that going into this one, and I did, I think, 10 bottom layers, which appears to be enough. Because I think, if I'm not mistaken, alcohol is a little bit thinner than water. So we put some alcohol in there. We'll set this to the side and check on it in a bit and see if it has leaked at all. Because sometimes things will appear to be watertight, and then you kind of let some time pass, and they're not. But anyway, let's try to solder some of this. We'll start with this 5mm piece. And again, is our focus okay? Seems reasonable. Too bad the alcohol will evap before you notice. It should be in there long enough. Gusner, 19 Celsius here in Belgium. Had to work in the garden. Yeah, it's like normally if I wasn't streaming, I'd probably be outside working in the garden too. I garden every year. I'm kind of excited for that season to come again. So let's do a test here. Like, obviously, if we touch this, that melts instantly. I don't know if you can see that. That just, like, because it's so hot. This is 650 degrees, which I don't know what it would be in Celsius. Pretty toasty. But we're going to see if we can get some solder to stick to this. I guess first we'll just try... Let's prep one of our little wires here. Let's get a little bit of solder on there. We'll actually get quite a bit of solder on here. As much as it'll hold. Should I get a blob on there? There we go. Get a blob of solder, and we'll get a blob of solder on our iron. Not generally how you solder things, but see if we can get this to stick. I already kind of am anticipating the answer is no. Oh, I thought we had it for a second. I think it's just kind of the wire melting melting into the plastic. Let me clean this tip off. Maybe that's something you could do. Maybe if we apply heat back here on the wire, we can actually just like melt the wire into the piece. Oh, I think we're onto something. Oh, shit. We're pioneering new techniques here. So, I don't know if it's super obvious what I did there. I was heating the wire itself and then just, like, melting it into the end of this piece. Hopefully... I need to make this window big a second so I can see the focus. It's kind of hard to see the focus. Hopefully that's reasonable. Is that reasonable? But yeah, there I melted that wire into the end of this piece. So I don't think the solder is ever actually going to hold, but that's actually got a pretty good grip on that. So let's see now if we have enough juice to run our LED. Oh, it must be the other way. Damn it. Heyo. So it looks like that might be sort of like a weird option there, if you do need to solder into these circuits, is actually just heat your wire and kind of get it to fuse in there, because like I'm pulling on that pretty hard, and that seems to be embedded in there fairly well. So that might end up being one of the easier ways to integrate wire into circuits that have this filament in it. Interesting. You could actually let's go ahead and try another one here. You could actually use this material as like a resistor, though I would imagine it would melt fairly easily. I wish I had a bench power supply so we could just apply current to these until they melt. Let's try another piece. Again, we're just like heating the wire and pushing it into the filament. Which admittedly makes a bit of a mess. You're not going to like win awards for how clean your circuits look, but so there we've basically made like a makeshift resistor. The graphite definitely conducts heat. Like this piece is pretty hot. Cool that off a bit. And I'm pretty sure we should have a working circuit still. Yeah. Very cool. Oh, Gustner, I think Gustner said, did you say that before I'd started doing this? About heating a paperclip? But, no, that's cool. So there are some options. So maybe the kind of low melting temp of this material could be an advantage if you kind of work around it. I wish I would have thought about it beforehand, but I wonder if we could improve the conductivity of these by annealing them a little bit. Like basically putting them in the oven. Freaking focus on these cameras. Terrible. Okay. So I would assume we're nearing our color change here. Let me get my window here. So we didn't really, I wouldn't say that we soldered this filament. I mean, I don't think this really counts. And like you saw, we're not really able to actually get solder to bind to this at all. Like we have a little bit that's sticking there. But I think that's just kind of melted. Yeah, as soon as I actually heat that, it doesn't stick to the plastic at all. So I don't think soldering this, I don't think it has enough. I don't think it has any metal in it. So, yeah, you're going to have limited options as far as that's concerned. But this is definitely fun to play with. At the very least. I don't have any paper clips on hand, or I would try that. But I wonder if we're able to at all melt like these thin pieces in a way that's kind of like not a mess. Do we get it? Because it does seem to stick fairly well to the metal in this wire. I mean, that's a little bit messy, but there we've kind of fused them together, even this little thin bit. Let's see if that conducts enough. It's quite a bit dimmer, but that does conduct. So yeah, there's all kinds of stuff you could experiment with. Obviously, like that, I just broke that, but very cool. All right, so now we're basically going to wait. It looks like we're nearing our color change, which, like, I'm excited to see this little circuit printed, but I'm not really looking forward to the purging the filament. We'll have to try the atomic pull. Can the filament be tinned? It appears not, because the solder is so much hotter. The solder is hotter. The solder, for those of you not in the States. Like, I prefer to say solder, but people look at you like you're an idiot here in the States if you call it what it's actually supposed to be called. But it looks like, no, you can't really tin these parts. Just because the melting temps are so different. And the melting temp is so low. In the, let's try autofocus. It never works out, but we'll give it a try. But the solder doesn't seem to want to bond to the filament at all. Like you see there, it'll just wick up the iron. I mean, I'm being about as aggressive melting that filament as I can be. And you can see it's just not really something that's going to happen, I don't think. Because there we have a big old blob of solder. Oh, I'm sorry, that's out of the shot. Big old blob of solder that I'm about to drop on my palm. And it does not want to bond to the filament at all. So, no, trying to solder this stuff I think is a bit of a pipe dream, which I kind of predicted that. How many LEDs can light up before it melts? Well, we can, I think the easiest test for melting it will just be to take, like if we take our 12-volt source here, and then especially with these thin pieces, like with this, this 1mm piece, like if we just hook it straight up and make a little makeshift particle accelerator. Or I don't know, it might have so much resistance that it just doesn't... Oh, it's getting soft. It's heating up a tiny little bit. But I don't know if 12 volts is enough. Like it's getting kind of warm, but I don't think it's actually going to melt it. It just like it warmed it up a little bit, so it's like nice and flexible. But that's about it. We could, again, positive, negative. We could try, I could try jumping in this extra battery pack. So that would take us to what, 15 volts? So there's 15 volts, but it's still just, it's just softening a tiny little bit. I don't think that's actually enough to melt it. So yeah, I just think we don't have enough juice. We have enough juice to throw some sparks, but yeah, I wish I had a... Oh, I wish I knew how this flyback circuit works. I can't remember how that works. We can let's play with this for a minute, because if we can get this flyback working, we definitely have enough juice. Let's see if we can... Anybody that doesn't... No, we're not going to try mains voltage. But we'll try to get this little flyback circuit to work. So I've got my little 9-volt fan here because this transistor gets hot as balls. I do remember that. So there we've got our little fan running to cool our transistor. And if I recall, somebody be ready to call the paramedics. This definitely gets filed under not safe. I don't think I have enough gator things. So we'll have to solder. We'll solder a couple of these leads here. We can go ahead and I guess solder our voltage on, which is probably a bad idea. But we'll what's the worst that could happen? So we'll go ahead and solder our negative on here. YOLO, right? As the kids say. And this is going to be like a really ghetto solder job. I guess we don't need the fan now. That's like keeping our solder from doing what our solder is supposed to do. I think we'll just solder these on the underside because we have an existing joint here, so it'll be easy to kind of solder into it. Ghetto solder complete. Melt, you bastard. Ow, I burnt my finger. That's just such a huge blob of metal there. It doesn't want to, doesn't want to melt. We're going to get it. We're not going to give up, right? We can do this. Because if we can get this functioning, which I think we should be able to, we will definitely have enough voltage to annihilate this stuff. What the F? What the F is going on here? Okay. There we go. We got it. And let me make sure the other one's on here. It just always blew my mind, like, how much angry electric action you can get out of a flyback with a few volts DC. Okay, so there we have our power hardwired in. That could never go wrong, right? That could never be a bad thing. We have our little fan going. All right. I'm going to try not to die here. I still don't have enough little gator tie zip things. Damn it. I used to have a ton of those. So maybe I don't need them. I don't know. Like I said, somebody be ready to call the paramedics. This is not safe. Well, that doesn't do anything. I don't remember how this works exactly. There we had sparks of some kind. Yeah, I don't remember. F. Man, I wish I could recall how that works. It's probably been 10 years since I made this thing. Use fresh solder on the tip. So let me look really quick. I know I have a ton of gator clips around here. They're here somewhere. Hell, let's just make some. I'm anxious to see if we can get this working. So we'll throw some clips together quick here. All right, so we got our wire, we got our iron, we've got some clips. I guess it'd be easier to hold the clip in here. So these have like a pinch fit and then like a solder, and then we'll solder them after we pinch them, which make it a lot easier. So fold the tabs over on our wire, which kind of traps it, which actually might be enough for our purposes, but we'll go ahead and solder these just to make it as safe as possible, right? There we go. That's a little toasty. Okay, so there's one. They're easy to make. This wire isn't ideal, but that's not a problem. That's not a big deal. These ends are a little bit tougher. We'll just have to solder these, because these ones don't have the little grabber tabs. But that's not a big deal. That's one of the nice things about having a sweet iron, is that this will easily get this hot right away. Because normally with my old piece of shit like Radio Shack iron, heating up a piece like this would have taken forever. Like actually soldering a big old clip like this. Good enough. Good enough for government work. I guess let's do the big clip first, since they're a little bit tougher. But is anyone else here into like electronics? Like, I'm a complete amateur if you can't tell, but I have messed with quite a few different things over the years. It's just lately, and I mean lately as in like the last 10 years, I haven't messed with much of anything. Good enough. This is like shameful soldering quality, by the way. I apologize if any actual talented people here take offense to my shit soldering skills. But normally I do a better job. Normally I'm not like in a ridiculous hurry like this. Most of my work is actually fairly nice, I'd like to think. Especially the work I do in like consoles and stuff behind me. I try to make that as nice as I possibly can. Since some of those things, hopefully, like I'd like to think that some of those consoles I've modified will be around for decades. Because I usually put my little calling card on the inside of the case. If anybody ever finds any. They might be able to tell that it was mine. And generally when you're soldering, I don't know if you see all that smoke rolling into my face. There's our color change. Oh, I was going to say it didn't beep. What happened? I thought it just stopped after the initial PLA layer. Okay, so it ejected properly. We're going to trim the end on our graphite. And we'll just put it beside the roll here. And hopefully, I don't think it's quite as bad going the other way, like purging the green. So hopefully it shouldn't be as bad. All right, I think we have enough here to get this dangerous thing working. And if you guys are wondering why I've said this thing is dangerous, if I do get it working, you'll see why. It is ever so slightly terrifying. So, hook up, hook up. All right. Like I said, if I fall off the table, someone call for help. Let me get as much conductive stuff out of the way here as I can. I'm getting, if anyone's ever worked with electronic stuff or like high voltage stuff like this, I'm starting to get that like that giddy feeling of that like I might die, but it's kind of exciting. It's probably similar to what like skydivers experience. Oh, yeah. Okay. Okay. Okay, this works. Let's disconnect the voltage source. Okay, I got it working. Oh, we are going to annihilate some of this filament. I'm going to need to take a bathroom break. We're going to make sure this color is purged. It missed the teeth initially when it started like pulling the second color in. But oh, I'm so glad I got that working. Oh my goodness, guys. Oh my goodness. I can't believe it still works. That's so cool. Okay, we are underway. We have our graphite loaded. There's a little blob there where it started back again, but I'm going to take a really quick bathroom break, like 30 seconds. I'm going to use this stupid thing that people have been telling me that I should be using, and talked about it on another stream. Not a big ad guy, and I would encourage most of you to be running like ad block or something, but I'm going to play an ad really quick while I run to the bathroom, and we'll be back, and we're going to either kill ourselves and or annihilate some filament, or I'm going to trip a breaker. Wow, that's right. I'm not into the mains power, so we should be good. So I will be right back, guys. All right. I shoved some Cheetos in my mouth. I got what's left of my coffee from this morning, which I probably don't need given what my pulse rate probably is right now. We do still have alcohol in this, and it's not seeping or leaking at all, so it does appear this is watertight, which is kind of cool. If anybody prints one of these, it looks like 5 layers is not enough, and 10 is. If you're trying to get the bottoms of those watertight. Okay, I'm going to take one minor precaution here. I'm going to take a big old paintbrush. And tape it to the lead of this thing. So we have a little bit of insulation between this. And I don't know exactly how you'd calculate how many volts this is. It's a lot. It's quite a lot. Luckily, like from my understanding, this should be fairly low amperage. So we shouldn't die. But I have like briefly shocked myself with this thing, and it hurt really, really bad and gave me a burn like immediately. Alright. And needless to say, don't try this at home. That's my personal advice. All right, let's go. Let's do this. So, what we've got going on here, and we don't have this hooked to power, we have this little board, and what this board does is essentially, it's just a transistor. The transistor is here mounted on this heatsink, and it's basically just like turning the voltage on and off really, really quickly, right? And little 9-volt is running the fan to cool the transistor because it gets extremely hot. And then we've got a little, it doesn't seem like a lot, but we've got a 12-volt DC power source here with 8 AA batteries. And we're gonna try to get this positioned in a way where we don't get a short where we don't want it. So we'll have that setting off to the side. And what this does, again, it's been about 10 years since I messed with this thing. But I was actually building this as a driver for a Tesla coil. Is why, if anybody's wondering, this is why this came to be. And what this actually does is takes that 12 volts, and it would be 12 volts, and I think these are like 1. I forget how many amps a AA battery is. Not very many. But it is DC. So anyway, kind of irrelevant. But what it does is it has these coils in here that... Yeah, like I said, it's been a long time. But anyway, it basically changes it to a really, really low amp, super high voltage kind of situation, as opposed to being like a lowish amp, lowish voltage. So we're going to hook our batteries up here. And hope we don't die. Like I said, this shouldn't be lethal. It would just be exceptionally painful. But it looks like it's a little weaker than it was when I had done this initially. But you can see, I can smell ozone like immediately. We've got about a 1-inch arc there. I don't know if you can see that. It's a really hot short arc. Hopefully it doesn't, the EMI doesn't annihilate the camera. Where is that best? But you can see it's pretty angry, right? So let's take... Oh, how do I do this? I don't know how I'm going to do this. Let me... How do we want to do this? I need to, like... And we need to discharge that. Okay, so let's get a piece of this filament here in the circuit. Which I guess shouldn't be too hard. We're going to use one of these other gator clips I have, right? And let's get rid of the autofocus and try to focus this. But yeah, it's plasma, basically. Chris Olds. I actually built one of these that was much, much larger. And I quit messing with it because I was afraid I was going to hurt myself. I actually had about a 75-pound pole transformer that I got from someone that I used to run off of mains voltage. And that thing would arc about 10 inches. And like I said, it scared me. Like, it was actually scary. And if I would have done something stupid with that, it probably could have killed me. So it seemed like something I didn't really need to be doing with myself. But anyway, let's gator clip one of these on here. We'll start with this thin one. So there we have, and let me get something light. Let's get a handy dandy piece of paper of science. Okay, that is much better. That is significantly better. Okay, and I wish this had a bigger lead on it, but 'tis what it is. So here is our 1 millimeter piece of filament, right? This is the conductive graphite. So I'm hooking the battery up, and we're gonna see if this will. We have an arc there. Get that where you can see it better. I'm just kind of afraid to get the camera too close. I don't want to like fry it because there is a crazy amount of electromagnetic interference around here. So it does conduct. Not very well. Like you see, if we go straight to the metal, we get quite a bit bigger arc. But I don't think it's actually melting it. There's like a nice steady arc. But I don't think it's quite, I don't really think it's melting it. Huh, I'm kind of surprised that that's not melting it. You think that would be extremely hot. But it doesn't appear to be. And you can tune this. There's a little bit better. I know it's kind of hard to see there. Let's bring the gain down a bit. Actually, quite a bit. But, yeah, not a super huge arc. But we had already kind of tested this, and this piece had a fairly high levels of resistance. So let's try. That was our 1x1. I know we had a 3x3 piece, but I kind of like lost it somehow. Let's try the 5x5. And this piece has this is the one with our metal, our wire leads melted into it. So I'm actually going to try to pull them out. Which isn't too hard to do. Got them out. We can leave one on the end because it'll make it a little easier to interface with this probe. And you can see this one does conduct a little bit better. Again, I'm kind of surprised it doesn't end up melting it. And you can see we conduct really well where the end of that wire is inside the piece. But then still not quite as good as we do with the actual like metal probe. We might be killing the batteries. See if I can get this arc a little bit bigger. But yeah, it does. I'm just like really surprised that's not melting. Surprising to me. I really thought we'd be able to melt that with that. Huh. I can't believe I lost the 3mm one. Or did I only have a 1, a 5? I had a 1, a 3, and a 5, didn't I? I thought, here's a piece of just the filament itself, just straight. I was kind of curious, like, how well it conducts. We never did test the resistance levels of just the filament. There that burnt the, But yeah, it's just not melting it. I'm kind of surprised. And the tip of that is really fine. But it seems like you could leave that there kind of conducting for some time. But yeah, that piece definitely conducts better. And then I don't think we can get the big boy on here. I think he's just like too big. I don't have a clip big enough. But yeah. Huh. Well, 25 millimeters, about 20,000 volts. And I would guess it depends on like the position, like because it's sort of like water. Like if you get it flowing from tip to tip, the arc can be a little bit bigger, but I would guess that's distance wise, I don't know. That's probably 15 millimeters or so at the widest. But I wish you could see it a little better. There's all kinds of different configurations you can run these in. Like, let's pull the batteries off. We do have a second battery pack here. Could try to get it to I guess we can do it while we're all sitting here together. I'll solder in this second battery pack. Then we'll take it up to 15 volts DC, which isn't a lot higher, but might be enough to get something a little bit easier to see while we're waiting on our print to finish. If I can get, man, like a third hand, like obviously I have my little helper things, but a third hand when you're soldering would be so great. Because you're always like trying to hold two things together and then operate the iron with your third hand. That's not too bad. Oh, I did it backwards. Shit. Yeah, you don't want negative to negative. You want positive to negative. Idiot. I guess I am doing it off cam. I was going to say, who's here checking me? This is where I need, like, the oversight of chat. Before I do something stupid. Which I think we've already crossed into doing something stupid, like, long ago. So I guess it is a little late to worry about that. But yeah, there's, if anybody's interested in this stuff, there's slightly safer things like this you can do. So they were going to be at 15 volts DC. Which might make a difference, might not. Definitely did. I mean, it's not a huge difference, but I'd say we increased the arc by about 10%. But that's not too shabby for a little ghetto setup like this. You can definitely smell the ozone, and you shouldn't really look at these either. I think this stuff is pretty hard on your eyes. Obviously not for you guys because it's going through a camera, but for moi, it's not ideal. All right, so let's try this 5mm piece again. It's probably still not enough to melt it. I just like can't believe that that's not melting this filament. But you can see like it conducts very erratically because I guess the actual part of the filament that conducts is so irregularly dispersed. I'm kind of surprised that isn't interfering with the camera at all. But yeah, I guess we've tried this enough. And it is not soft at all. It's not even warm, surprisingly. Which does really surprise me. Because whenever, like I said, I've shorted this out on myself a couple times when I was like trying to get it set up. And it gave me little burns, like instantly. I'll discharge that. I'm going to swap these wires around and see if we can get... if changing the configuration here... will change anything. I don't think that's going to work. We can try it. Because worst case scenario, we burn out the transistor. Yeah, we have incorrect flow. There we have a stronger arc, but it's much smaller. Like I said, there's all kinds of different ways you can configure this, which is kind of why it's fun to mess with. Like that's a much more aggressive arc, but it's shorter, so it's probably like higher amperage, lower voltage. It also makes a lot more noise. Still not melting the filament though. I'm like shocked. Let's take our thin piece. We'll try one more thing. We're going to take our thin piece and actually just like complete the circuit. And it's still not melting. I guess the amperage is what's actually going to cause it to melt or whatever. Kind of crazy. Anyway, I was really hoping we were going to like be able to push that to the point where it kind of failed and melted, but doesn't look like that's going to happen. But anyway, wearing a, it's tungsten. It's tungsten, man. Let's see how well my ring arcs. Like obviously tungsten's conductive, but. Yeah, wedding ring arc action. Woo! Good old tungsten. Would have been cool if we could have made my whole ring glow. Now see, my ring is warm. I don't know why the filament wouldn't have been. Anyway. Let's try one more thing. The batteries, like this is, it's kind of crazy to me that this is such a stable setup. Like the batteries aren't really hot. The only thing that gets hot is the transistor gets hot. But the little PC fan is more than enough to kind of alleviate the heat that it generates. That's with a slightly different setup again. Again, it's basically the same kind of thing, but anyway. Anyway. Our print's almost done. So I don't really think we can use this to test a circuit or anything. We can annihilate an LED. That would be something I've never done before. Let's try that. I'm sure it's just going to, like, explode immediately. So here's an LED. Oh, it works. How does that not just explode that? I guess it's like the same deal, like the amperage just isn't high enough. Interesting. I would have expected that to, like, explode immediately. So apparently you can run an LED on several thousand volts if the amperage is low enough. Well, what am I being asked here to do? I'm surprised no one has asked me to just, like, stick my finger in there yet. Yeah, Joachim, I guess that is the case, that most of the heat is in the arc itself and not anything actually conducting. There's a thing. Oh, yeah, I actually have one of them sitting here, Frederick. A little like, helping hand thing. I was using it earlier, but you know how it goes. Like, you cut corners to save time, which ends up costing you 3 times as much time. Yeah, wow. I was not expecting an LED to survive that. I guess if you knew more about electricity, which I admittedly don't, it's all that kind of stuff of, you know, it's all the same things, just in different amounts. That made me sound even dumber than I actually am. That's not how an LED is supposed to work. Oh, there we got a little bit of heat. Anyway, that is a very unpleasant smell. And that's just because that plastic was in the arc. So let me clean this up. We survived. This kind of makes me want to build a bigger one now, because this one's kind of cool, but it's not as cool as having, like, 8 and 10-inch arcs. The ones where even, like, bystanders that are standing 10 feet away are kind of, like, nervous that something bad's going to happen. But anyway, cool little diversion there while we wait for a print. Everybody, like, you can get bigger arcs too using, like, an actual power supply. If I'm not mistaken, I think you can get up to 24 volts out of these. Because they have, like, this one has two 12-volt rails at 4 amps, which is quite a bit of juice for something like this. But anyway, let's get this out of here before I shock myself. I would like to do a little bit of looking, because I would like to stick my finger in the arc and experience that. Because if it's not going to kill you or stop your heart or anything, and it's just going to, like, hurt really bad for a short period of time, like, I would be willing to do that. Yeah, I did, Ralph. I discharged it before I touched it. Anyway, just another day in the shop. But no, it's actually, I never really thought about it. I would actually be able to produce a lot of the components for making a Tesla coil. Because there's a lot of things you end up, like, there's guys that end up making some of the parts out of wood and stuff, and PLA I don't think conducts at all. Unless I'm mistaken. I think PLA is, like, completely non-conductive. Because there's a lot of parts for, like, spacing the rings in the base, for instance. You could actually 3D print the tube that you do your magnetic wire windings on, or your magnet wire windings. There's all kinds of stuff you could actually do to help you produce a Tesla coil. Could actually try to even integrate some of the conductive filament into it. So let's move this over here. We'll take a look at our print. Oh, that's right. I dimmed that like crazy hard. Where's that at here? Yeah, let's take a look at our print here. It's about 96% done. And it is a cool looking little part. I think I did make it public. It's on my Tinkercad page if anyone's interested in messing with it themselves. I guess you can't really see it, but it definitely looks cool in two colors because we have obviously like our green PLA base and then our all the traces, the super thick traces on the top are printed in the conductive material. But we basically already tested everything we're really going to test with the board with the conductivity and the LEDs and stuff. But we'll go ahead and do some tests with it just for the sake of completion. But like I said, this is public on my Tinkercad page. If anybody wants to print this little printout, and you happen to have some of the graphite filament, because I think this with a couple gator clips and LEDs, if you make yourself some little holes, which like someone mentioned earlier using paper clips, that would probably be a really easy way to make the holes in these traces for your LEDs to insert them. If you just take a paper clip and like obviously heating it up with soldering iron would be the easiest way to do it. Just hold it with a piece of pliers, put the soldering iron on the clip, and you could melt yourself some really nice clean holes to just like slot your LEDs right in there. But it seems like this stuff over extrudes a bit. I don't know if it's because we printed it so hot. Like I think I printed this at 230, which is the high end of the temperature range. They suggest 190 to 230. And there we're done. Excellent. You see, it's a cool little print. The freaking lighting back there is not ideal. Let's just get it off of there. That'll be the easiest way. Very cool. Two color pieces are always cool, though. But there you see it. Couple different traces in different sizes on our nice green base. And I'm going to take one of these... I have these little wire brushes that I got like a long time ago. And we will just... Where's that in focus? We'll take this, and you can see there's a little bit of like stringing. Not really stringing, but because it over extruded a little bit on those top layers. And we also have a little bit of a blob right there where this started printing on the PLA. So we'll clean that up a little bit so this looks nice. Easy. And I guess I'm going to clean these top layers up. They're a little rough. If you've ever had like filament that seems like it over extrudes and then the nozzle ends up kind of roughing those top layers up. I'm just going to run the blade across that and smooth it up a little bit. Make this a little more presentable. This filament is kind of soft, and I would guess like that, being that it has super fine powder in it, it makes it extrude like really smooth. It's almost like kind of milky, which is kind of cool. Because some of these filaments, like obviously, like the biggest appeal is that it's conductive, but some of these unique filaments end up having textures and stuff that you really can't get out of other PLAs. So it might have some application outside of conducting electricity if you kind of want that milky, velvety texture in like a black filament. All right, not too bad. Get rid of the extra there. Brush this a bit to clean it up. But cool little piece overall. It makes it look nice that we have the nice consistent pattern of the infill and the green behind. And then, I don't know, it almost looks like a weird symbol of some kind. And especially with the height being varied across the traces and stuff, it's kind of cool. The green looks funny on camera for some reason. The green's like way richer here on my end. I guess that looks a little bit closer. I don't know, it's like the saturation's off or something. That looks a little bit more like it does to me. Whatever, close enough. You guys get the idea. So what we're going to do, we have our little battery pack, which we have bastardized into our little home electrocution kit. And we've got a pair of gator clips. And I would try to use this 3-volt, but I don't think the 3 volts is actually going to be enough to drive an LED when we factor in the resistance that this stuff has. I know there's equations that you can use to figure that stuff out without having to actually test it, but let's take a look here. And we'll put this on DC volts on auto. Right? Right? Let me move this light. Try to get this illuminated slightly better. And of course now it's going to glare on my my voltmeter here. Let's move it to the other side. There we go. But you can see that the green comes through a little bit better there on this board because it is cool looking. So there we have our voltmeter. And I don't know why it's saying we have... There we go. Have that. Have our little battery pack here. And let's just hook this up to these circuits and see how much voltage we end up having at the end of the circuit if we start with... let's start with 3 volts. We'll double check, because we did kind of hit these battery packs pretty hard. That little setup. We'll see what we're starting with here. So we're at like basically 3 volts still. We're at basically 2.9 volts, which isn't bad for a pair of AA batteries. So yellow will be our negative, red will be our positive. And let's hook these up to these traces and see how much voltage we have at the end of this and see if we do have 3 volts to actually run these when it's all said and done. I don't know where to put my hands. I'm in my own way. I guess we'd be this way, right? Interesting. We're at, well, it's negative. I guess I have them backwards, but it looks like we still have basically 2.9 volts there at the end, which I'm kind of surprised. I mean, that might make sense to someone who understands electronics better than me, but I'm surprised the resistance doesn't affect that negatively a little bit more than it seems to. So we'll just touch an LED here. Spread the legs a bit. That's what he said. And see if that's enough to illuminate the LED. I wouldn't be surprised if it's not. It doesn't appear to be. Let's double check that this LED works. It's possible while we were on our little LED frying rampage that we kind of killed it. This is one of the ultraviolet LEDs, so it does appear to work. 3 volts is definitely not driving it very hard there. But it seems like we just don't have enough voltage when it's all said and done to get any light out of that at all. So let's hook our 12 volts up. Again, it might just be the case that we technically have 3 volts at the end of those traces, but we don't have enough amperage to actually operate the LED. But we'll give this a quick and dirty test. Oh, don't break my LED. No. I mean, it's working, but man, that's like... I guess it's hard to get good contact. There we do have it working. It was working. There, I don't know if you can see that. It is illuminated, but just ever so slightly. I don't know if we don't have good contact. Yeah, it's just like, it's have really bad contact, I guess. So let's try and let's see if we can just melt this LED directly into those traces. Maybe that'll help. We use the same thing we kind of did on those wire leads, because it is a really easy technique. Just basically like putting heat on the legs of the LED and kind of easing them into those traces. So there it's actually attached quite well. Let's see if that helps with conductivity at all. It doesn't seem to. I don't think I switched polarity either. Nope, I must have. Like an idiot. So there we do have it illuminated. You can see that kind of like blue, hazy halo around it. So it does work. Let's see if we can grab another one here. We'll clean, because these were all salvaged from another project, so they have some schmutz on the leads here. Let's get them cleaned off a bit. Trim this one up. And I guess just for the sake of our own sanity, even though I switched the polarity of that one a little bit, we'll put this one in the same way, so we can just move our leads up and down the traces to do our testing. And I'll spread those legs nice. Take our iron and we'll melt, make sure they're going the right direction. And we'll melt these ones into these traces in the slightly thicker ones. I'm trying to keep them centered, but this is a little easier to say than do. It is kind of cool that if you would have an LED project like this, I think that's actually a sort of legitimate way of attaching your LEDs is actually just to melt them into the traces, because that's fairly securely fastened there. I mean, that's as secure as any projects I've ever done where, you know, you end up soldering an LED into place. All right, what's the deal here? Oh, I got on the wrong one. Did I have on the wrong ones? I don't think I did. Now neither of our LEDs are working. Oh, it is, but like that, there's the original one. It's really faint. Let's try swapping out some batteries. Maybe we killed this battery pack. It is possible. And we happen to just buy a 24 pack of AA's, so might as well use them. Because even those ones that we kind of killed, I can throw those in our like TV remotes and they'll probably still last a long time. Because I think these leads might have touched there for a little bit, and that's pretty hard on little batteries like this. These are the times I wish I had like a nice little like lab power supply. Oh, that's a little bit better. So let's see. These ones work? They don't appear to. Don't tell me I have them switched on this one. It doesn't appear to be illuminating on this trace. Maybe that LED doesn't work? I guess that's possible. Yeah, that might have been an LED that we blew. Ouch, damn it. Let's see if this guy works. Oh, that's right. That's right. I just blew this one. I forgot we we're using 12 volts, so it blows the LEDs immediately. Okay, so that one's good. Let's get this one mounted in there on these thickest traces and see how it functions. Bend these legs out a little. Because maybe this doesn't, we didn't really test the resistance of these ones. Maybe for whatever reason, since I printed this at 10 degrees hotter, maybe this doesn't have as high resistance as some of the other ones. Oh, those values are so... Like, how are these values so much different than what we were getting before? Does the PLA affect it? The PLA, this is just on the green. The PLA seems to be completely non-conductive. And then these, like, I'm really stabbing those in there. How does that have values that erratic? That's crazy. That's kind of crazy to me. Here's the thicker one. See, that's a little bit closer to what we were getting with just the printed rods that we tested. Let's try the other side on here. And there, that's I think this is about a 5mm by 5mm trace. And that one's giving, this is pretty much what we experienced on the 5x5 rod, I believe. was about 1.5 kilo ohms. And then this one, like, what is the deal with this one? Oh, see, there it's being kind of consistent. Here's the thinnest trace. Yeah, why were we getting such weird values there for a second? Like there, 13 kilo ohms, 10, 8. It looked like it hit like 40, 19, 27. This is some weird material. Huh, that's kind of weird. Scott, what we're doing is we're testing the green is just regular PLA. The black is the conductive graphite from Proto-Pasta. And you can see we've got a really basic circuit here that's driving an LED on these thinnest traces. And we were trying to like try some different thickness on the traces. But yeah, we're getting like really erratic results. So let's test this LED with our 3 volts. Make sure it works. So this one works. This LED works. I know it's kind of dim there. But where is it? I can't touch everything at the same time. There we go. This one does work. So we're going to melt this into the thickest traces and see if it'll actually work, because it seemed like we were getting consistent results finally from these big guys. And what we're doing is we're just kind of like heating these legs and melting them in to the plastic, which I'm hoping gives us like really good contact internally there. Like we melted that into those thick traces there, and we'll see if... Okay, so this one does light up. Really, really squeezing the gator clips on there. I'll even use my pliers to help squish them in, and that does help. I can see the brightness of the LED increasing as I really smush them in there. But there it does work. I don't think, like in hindsight, I would probably design this little test board a little bit differently. And it would be interesting to see if you can actually get some integrated circuits and stuff working. But I don't know, with having such erratic results with like the resistance levels and stuff, I think it would be hard to design circuits around this outside of like, you know, basically using the filament as wire replacements and some basic like LED driving circuits or a light or a really simple motor or something. I wish I had a really simple motor here, but I don't think I have any. Pretty sure I don't. I have a little 10K potentiometer here. Might be able to vary the voltage. So there we have our LED. There's way down. There's completely up. Basically off, on. So you could do some cool stuff. Like I could see you being able to... Let me think here. Could melt this into here. Try to. Anyhow. But now I'll have to obviously I'm going to leave this video up. we should try to, as a community, get some like circuits together for people to mess with this filament with, since there really isn't much out there right now. And I think this would be kind of cool to get, kids involved or excited. Like, kids always like basic electronic stuff for the most part. But this would be a cool thing. But yeah, like there, we integrated a little potentiometer in there to basically bypass that LED. Melted right into the circuit. It's kind of cute. It basically acts as like an on-off switch. When the resistance is really high, the voltage is going to flow through the LED. And then basically when we open it at all, or close it at all, it's going to go through the LED until the resistance hits about 10K. But yeah. No, so I have to like put it out to you guys. I'm probably going to mess with this a little bit and try to think of some like cool little circuits you could print out of this that would be fun to mess with. You could maybe, if any of you guys have kids that are, after about the age of 5, this stuff becomes interesting to kids. Because I think this stuff has a lot of potential. I don't think it has a lot of potential for like serious electronics, but yeah, as far as just like playing around with it and stuff, I think there's a lot of potential here. Because I mean, I know it's not as fun for you guys because you don't get to play with it, but like I'm having fun sitting here messing with this. Tiles with LED lighting. Yeah, that's actually. I saw there's a company that has been trying to integrate LED lights into their stuff, but they're not using like conductive filament. But yeah, that would be something that would be cool to do. I think it would be best if you had like a dual extruder. Oh, that's right, I changed my lights. My big old head's bright as hell now. There we go. No, but that would be cool to do. So you could actually just have like your little button cell batteries like right in your tile instead of having to run, something like external that's gonna, be kind of an eyesore on the table and stuff. Motorized traps and doors. Getting a little ambitious there, but that would be cool as hell. Yeah, that would be cool as hell. But no, hopefully some of you guys are willing to mess with this a little bit. And maybe we'll try to get a small collection of cool little prints that people can mess with this kind of filament with. I think one of the toughest hurdles as far as providing prints for people is the fact that like with this print, it's fairly straightforward, but doing it with the 2-color, like you actually need to basically provide people with a G code that has the color change in it. If you are kind of gearing this towards people that are completely new, it might be a little intimidating for people to use the utility to do the color change themselves. Do we measure the resistance? Yeah, we actually, like I'm assuming you joined recently. At the beginning of the stream, I had some different thicknesses printed out here. Where are they? I don't know where the thickest one is, but we had like basically a 1 millimeter, a 3 millimeter, a 5 and a 10 millimeter, kind of just a straight rod, basically, like these, and we were testing the resistance of them, and it's kind of erratic. I think like we can go ahead and do one here while I have everything set up. But I think on this test piece, there doesn't seem to be a whole lot of reduction in resistance going from 5 to 10. But some of the other pieces, like obviously the really thin pieces, see, half a kilo ohm. Yeah, the results are so erratic with this for some reason. Like I thought earlier we were getting basically 1.5 kilo ohms to 1.2. And they're like just moving the probes around. like really changes things. Like it's kind of crazy how erratic the material is. And then the top layer seems to be the worst of all. Like the bottom layer and the sides seem to have the best conductivity, but they were at like 2 kiloohms. And there the probes are closer, and we have like a higher resistance. Like it's just it's so weird to me. This is a very strange material. But it's fun. It's fun to mess with. Like I said, for like basic electronics projects and stuff, I think you could have a lot of fun with this. Especially, like, I'm not saying you can't have fun with it without children, but obviously it'd be a lot of fun to sit down with a younger person and do some stuff with them. You could probably also, like, I know they have those kits that use like basically buttons, or not buttons, like what do you call those, like snap buttons, where they have like basically like modular electrical components. Like I could see printing some of this stuff out of that, or for things like that. If I'm not mistaken, I think I want to say Shep, who also has like a YouTube channel, I think he did some of those recently. No G code needed. Done it a few times on my Prusa. Yeah, you can. Scott's totally right. You can just kind of babysit your print. Like we could have done that with this, and as soon as we see it doing the top layer of the green, instead of actually having like a color change queued in there, you can just do like a manual color change. There are still some limitations. I guess you could also manually change the extrusion temp, because like on this, the PLA was extruded at 190, and the actual graphite was extruded at 230. So I actually did like a dual color and a dual process in Simplify. But you could just like manually edit those values. And I guess it wouldn't be that hard to just write up a tutorial to accompany the files, but I think it would be a really cool little project if any of you are interested, to maybe like as a little community here, get a couple prints together that people could use to experiment with this kind of filament, and we could like upload them on Thingiverse or something as like a little like compilation of maybe like 5 to 10 prints or something. But yeah, Scott, no, I think that is, like, it's inevitable that people are going to have to learn how to use their machines. So I guess it's not the end of the world to have a little tutorial there for someone to, use the little Prusa utility or whatever method they want to put a little like a G-code queue in there for the color change, because it definitely makes it a little more foolproof. That way, if you're not actually babysitting the print, you don't end up missing the spot that you want to put that color change in, and kind of screwing yourself. But I could already think of a few little circuits that we could make that just kind of like utilize, basic components like little potentiometers and stuff like this to do some cool little things. Maybe instead of using LEDs, use like little actual light bulbs so you can vary the voltage to them and change the brightness and stuff. But overall, it's a cool filament. Proto-Pasta is definitely one of the cooler companies out there making filament. It's kind of shocking considering their size, like how many really unique filaments they have. And there's people that are copying them. Like I'd honestly, I shouldn't say that. I don't know who actually made the first conductive filament. It might not have been Proto-Pasta, but I know theirs has been around for a little while. Because I remember when I first got my printer, it was like one of the first filaments, and I'm like, ooh, I need to get that. I want to play with that. Shane, how is this on the extruder? If you watch, I have my little Christmas tree of shame here. You are right. Like when we actually changed the color, I think when it was all said and done, I had to extrude like 350 millimeters of filament to actually get all the color out. But you see, here's the little our little tower of shame. Let me see if I can focus that. Here's our little tower of shame. Because it actually extruded a good bit before this. And I think there's about 2.5 grams of filament here. Because it just kept extruding and extruding and extruding and was still like jet black. So I think in hindsight, the way to do the color change with this is to try to do, I guess it's a little tough to do an atomic pull in the middle of a print. I guess it's actually really tough to do that. I mean, there might be a way to do it, but too high resistance for bulbs. Yeah, I guess it would depend a little bit on like your power source, because we did have a little 3-volt setup here with 2 AA's, but that was not enough. I'm pretty sure, if I remember, that we couldn't even get... I mean, you basically get nothing out of an LED with 3 volts as your starting voltage. But then, like, we were prepared at the beginning of the stream because I was using 12 volts, and I think we ended up needing like a 470 ohm resistor to use a 12-volt pack with a 3-volt LED. And it just so happened to be the case that, like if you were watching, we were doing the resistance tests, that, again, it varied wildly, but the resistance on this filament is somewhere between, what was our range? About 600 to 1,500 or 2,000 ohms. So it actually works out kind of nice with a 12-volt battery pack. Like, your LEDs might be a little dim, but it's still like in that acceptable range for running them, where you're not going to like blow them out instantly like I did with about 6 LEDs. But no, overall it was a cool little, I don't know, it was a fun day, I thought. Yeah, the atomic pull, yeah, you're right, Johnny, it's right in that temp range. But the problem is if you're doing your color change in the middle of a print, which you're probably going to end up doing. No, actually no, because you're going to tend to be printing your PLA base first if you want to do it that way. I guess you don't need to. You could just print these traces out and glue them down or use them loose. But like a print like this, we only had the graphite filament in there first because I had printed these little test bars out. So I guess if you're just going to do boards like these, you're going to be doing your PLA first. So the purging in between colors isn't that big of a deal, because the PLA clears out pretty easily. So yeah, once you're done with these prints, then is when you could do your atomic pull to get the graphite filament out, because it does linger in there. Holy crap! Could make a pie case with a built-in wiring from pin. Yeah, it could be the case chain. I honestly don't know. I don't know. Especially like if you're doing an IR receiver, you're probably not going to want a whole lot of resistance in that, because I would assume that's a very low voltage circuit to begin with. So I don't know. You'd have to look. It might be an issue. It might not be. But I don't know. I would assume they had done testing with this, because I'd be interested to see if you could adjust the graphite to PLA mixture. Because I don't think it would take too much. Like if you'd increase the percentage of graphite in the mix, it probably wouldn't take a whole lot to start getting the resistance down to where you could actually do like really small traces. Because if anybody's like just joining us and you go back and watch the stream, I had printed out like a 1mm by 1mm trace that we were just doing some testing on, and the resistance was fairly high on that. I think this is one of them right here, because we can test it again. I forget what it was offhand, but it was fairly high. And I think with really small traces, you might run into some problems, getting useful circuits out of them. And we'll see, again, because this is probably going to be erratic as all hell. But the resistance was fairly high on these pieces. I mean, I guess that's not terrible. Let me move the probes around and see if that's accurate. Because I guess like that, like 8,000, almost 9,000 isn't like you could design circuits around that. You're probably going to have to start with like a higher voltage source to begin with to drive LEDs and stuff like that, but I think it's still doable. But I guess that's pretty much it. I know we did a lot of stuff. Again, anyone joining us like towards the end here, if you catch the middle of the stream, there's probably some stuff in there you might not be expecting on a Nillabean stream, but like someone said long ago, safety last. AK would be perfect for pull-up resistors. That's true. Like I said, there's so many electrical components. If you spend a little bit of time looking, that you can make almost anything work with a little bit of effort. So it would be cool. Like I said, if anybody has the desire, take a little bit of time in like Tinkercad or your CAD program of choice, and see if you can come up with some ideas for cool little circuits for people to mess with. And I think if we get a handful of them, I mean, maybe even if we don't, maybe if I just like get a couple together, I'll throw them up on Thingiverse. It's just like a little package for people to mess with if they don't feel like making their own little circuits to try the filament. You are measuring hand-to-hand resistance. Was I? I don't think I am. Because my fingers aren't touching. Because I was pinching the probes. I mean, you could be right, but I think my skin resistance is actually quite a bit higher. Like I know I moved the camera, but they're like the resistance through my own fingertip is right about like 1.5 to 2 mega ohms. So I think we're getting the actual resistance of the thing itself. I can hold it down on the table here. It should be right in that same ballpark. Yeah, right about 7 or 8,000 ohms. But then as soon as you jump up to the bigger pieces, like here's the 5x5, and we did F this piece up a little bit, but it goes down rather significantly. Like there we're at about 0.6 kilo ohms, and then the bigger piece, I think the gain's capped out at the 5x5 millimeter piece, and I think we were right down to about 600 ohms, somewhere in that ballpark. Same with this 10x10. And then again, it's so erratic. Like there we had 300 ohms. So we must have just been in a spot where it didn't have very good interconductivity. But yeah, between 8 and 600 are 0.6 and 0.8 kilo ohms. So if you make your traces big enough, you can get relatively decent conductivity out of it. Hand to hand is about 100. Yeah, I was just going like from a random point on my finger to another random point on my finger. But unless I'm mistaken, I mean, if I'm holding this material like that with maybe trying my fingers on the outsides, where the shortest path is through the material. I just broke it. You know what I mean? The shortest path for the current to go is through the material itself. Like my fingers are touching it, but it's not actually, shouldn't be interfering. And we're still at about, 7.6 to 7.8 kilo ohms. It's about 8,000 ohms. The cables do have resistance, but the meter generally takes that. They're designed to take that into consideration. Because there, if I just touch the probes together, we're at 0 ohms, 0.000. So, I'm not an electrician or anything, but at Nilla3D, find me on Twitter, we're discussing this week's Friday night community stream. Yeah, let me write that down. I will get in touch with you because it would be cool to hang out with everybody. I got my sweet Igus pen in orange. Never a bad thing. Country Cowboy. I probably don't even need to write that down. I think I can remember that. Country Cowboy. Where are you from, Matthew, that your Twitter handle is Country Cowboy? I guess my first guess would be Texas. Second guess, maybe Wyoming. Then maybe Tennessee, South Carolina. I'm going to laugh at if it is one of those. Maybe I could be totally off base. Maybe you could be in, like, New York City. Ah, you're in... Wow, York, Pennsylvania. You're actually really close to me. Yeah, you're actually really close. Because I'm in, like, not super, super close, but considering that we have a lot of viewers from, like, Germany and Sweden and China... Being in New York is pretty damn close. Because I'm down here in Pennsylvania, like right on the Maryland border in central PA, in Franklin County. So we definitely have a couple cowboy types in the area. Though we're mostly hill folk around here, I like to call it. People call us hillbillies, but we're not really hillbillies. We're kind of like mountain folk. Like we live in the Appalachians. So, yeah. Australia, what's up, Shane? Shane in Australia. I'm in a shack. I'm in a basement. I'm in my basement in my shack in the woods. Exactly. I mean, my family, my whole family is like in the lumber business. They own like a pretty big lumber mill. That's where I spent most of my childhood. That's why it's one of the, it's a benefit and a curse, is that I'm not really afraid to hurt myself. Because of the way I was raised. You just do stuff. You don't think about what might happen. You just get her done. Any plans on testing the Prusa MK2S? Absolutely. Yeah, as soon as they start shipping. And anybody that doesn't know, someone cued me in on this. You can actually, I don't know if they've officially added them to the site, but if you search on their site, they're actually on there, even though they don't come up in the store pages. So if you want to if you want to go ahead and pre-order yours, as far as I understand, you can, because I need to do mine soon. Earl's just outside of York. Pennsylvania in the house. No, I love living in PA, especially like the weather's going to get nice soon. We get to experience all seasons, sometimes in the same day. I know there's like memes about that for a lot of places, but... Yeah, PA is one of those states where the weather, especially around the Appalachians, because like we're kind of shielded from most weather, sort of. Especially like where I live, we live in a valley. So anytime there's really bad weather, we generally don't get it because it just doesn't affect us in the valley. But then at the same time, like there'll be days where it like snows and yet it's like 50 degrees and you get kind of weird shit like that. But yeah, unless anybody has any questions before we go here. Bloomsburg, PA. Man, I'm not used to this. I think when you look at my like channel demographics, like 70, almost 80% of my viewers are from out of the US. So it's kind of crazy to not only have a lot of you guys be in the US, but from like Pennsylvania specifically. Yeah, Ulysses. It's basically the same here. If you don't like the weather, just wait a little bit. It's probably going to change. Someone up around Erie and we're set. There's probably... I guess the chances are pretty low at this point, since we're down to like about 50 viewers, but yeah. No, that's crazy. The internet never ceases to amaze. 3D printed Aspie. See, that's what we're used to. Some like people in the UK. Like a lot of guys from Germany. I'll have to do a video sometime that goes over like the demographic information, because it is kind of crazy. It is kind of crazy. Lead times on the MK2S. Now, is that Scott? Is that the printer or the kit? Because I guess if they are that high, I need to put my order in before too much time passes. Because I would like to do that. I've been wanting to do. I mean, we've talked on and off about getting like some nicer smooth rods for weeks. Oh, you got your kit already? Damn it! I'm like, oh, I need to email them and see if they'll put a rush on it. Because I would like to do a review. Like we've spent a lot of time on the channel like messing with bearings and upgrades and stuff. So yeah, like I am anxious to see what kind of difference that makes. And I'm ready. I still haven't opened it, damn it, but like I got a decibel meter and everything. So we can do some kind of like objective comparisons and stuff. Yeah, it's about $50. I don't know, is that what you ended up paying, Scott? Was $50? I know some people have said the shipping's a little bit painful. Yeah, I've heard that the shipping is a little bit painful, which kind of sucks. Because I've seen guys say the shipping is like, I forget what, like $50 or $60 for the shipping. Do you mind sharing what you paid on shipping, Scott? Like, what was your cost to the door for the upgrade kit? Ooh, carbon fiber rods. Nice. I had considered for a long time like buying the IGUS, my cool IGUS pen, the aluminum anodized rods from IGUS, but I kind of talked myself out of doing that several times. Are the bearings in the MK2S the same as in the MK2? No, I haven't actually seen anybody do any videos on them, but they're supposed to be slightly higher. Well, I shouldn't say slightly. They're supposed to be higher quality than the ones that shipped originally. And hopefully that's the case. I don't know. You kind of never know until you get them. But I don't know. I don't think the low quality linear bearings were a huge problem in the MK2 itself. I think that having nicer rods would have helped a lot, instead of like the because from what I understand, the new rods are like nice like chromed rods. Peter. Well, see, Peter, I heard people say that. I've heard people say both things. I've heard guys say, like you just said, where the upgrade doesn't include the printed parts, but then I've also seen people say that they do include the printed parts. Oh, Scott, you got the... Okay. Yeah, that's basically what mine was. Mine, like, I got my kit for $6.99 also, though mine wasn't an S. And if I remember correctly, mine was $770 basically exactly. I think it was like 770.00 was the final cost. Because I think that total gets us just below where you have to pay like an import tax. Yeah, I wonder who told me that they do include the printed parts. They send you filament. That does suck. Oh, that does kind of suck. I gotta say, that does kind of suck. I mean, it's not the end of the world. I think I talked about that on stream before, where it was kind of a turnoff for me if you have to print your own parts. But it would definitely be nice. Like I like that I've printed. I think I'm up to I think I have over 1,000 hours on my MK2 now of print time. Probably well over that at this point. Yeah, Scott, that's some of the stuff you got to watch out for. I would assume Aaron's going to update that stuff for the changed case, but I don't know if he's done it yet. No filament for the Rambo box. What? Come on now. No, but like I said, I kind of complained about that before. That for the money, I guess they're I don't know what their justification is. I guess they're assuming that we all have the same printers they're going to manufacture it on, but it sucks to have to set aside. I don't know exactly, but I would assume you've got 10 to maybe 20, 15 or 20 hours of print time to print the upgrade parts. That might be a little high, but it would definitely be nice if they just like gave them to you. Does anybody, I know I asked, does anybody know what the approximate shipping costs were on the upgrade kit while we're talking about it? Oh, Scott, so he does have it updated. Fantastic. Yeah, Aaron's usually pretty good. I don't know if he's here today. I haven't seen him say anything, but Aaron's usually pretty good for keeping stuff updated. Like he definitely has a passion for the MK2. I don't know if because I'm like obviously I'm a bit of a fanboy. I'm here sitting in my orange basement. But it's going to be weird the day Aaron starts getting into other printers too. How long do you think it'll take for the first batch of MK2S clones? Not long. I think there's already some out there because I think Prusa has the. I don't know if they've released the upgrade parts like free for download, but 30 pounds to the UK. Oh no. 30 to the US isn't terrible, I guess. It still kind of sucks that it's $80 and you don't get the printed parts, I gotta say. Because ABS filament's pretty cheap. It's like if you take $15 off the upgrade kit and I'll buy my own damn filament and you just supply like the parts, the files. Did you get any free offer for 3D printers from manufacturers? No, I haven't. I'm looking forward to that day. Like I know it's funny watching like some of the other bigger guys on YouTube who complain about it because they're like, I don't have any more damn space. Quit wanting to send me printers. And I'm still like at the beginning of that journey where I'm like, no, send me printers. That's fine. If you want to send me a printer review, I'm open to that. But my biggest problem is I've been like waiting so long. Like I haven't done an actual review of anything yet. And I think that's part of the reason that no companies really look at me that way yet. Because I do like streams and stuff like this where we talk about things, but I haven't actually reviewed anything. And I've been kind of shitting the bed with my MK2 review. That's been in the works for like 3 months now. Have I asked anyone? No, I don't want to do that. I already went through like a few. It's been a few months ago. Like I asked a few companies for filament samples to review, and I felt kind of like a douchebag when I did that. So I kind of eased off of that approach. What are the dimensions for the enclosed for? I don't know. Like I know a lot of people use those. I want to say slack. I always want to call them slack cabinets, but that's not what they are. The I can't remember what they're called, but there's those cabinets that everyone uses that are fairly cheap, and they would probably be a good starting point for like dimensions for an enclosure that's suitable. We did make that. I did make that cheap ass enclosure for the MK2 because one of the weirdest dimensions is, and of course my tape measure is not down here. one of the easiest dimensions to underestimate is like vertically. Like if you want to have your filament mounted on the top, it ends up lac tables. That's what it is. The lac tables. But those would probably be a good thing to look into for like general dimensions because they seem to work out really, really nicely. Though, like I've been putting it off. I don't think mounting the filament on top of the machine is really ideal because that's a lot of weight, especially with like a brand new 1 kilogram roll. That's a lot of weight to have on top of your machine. And if you print fast, like if you've ever printed at like 50 millimeters a second or anything like that, your machine can get a little bit of rock just because it has that chunk of weight on the top of the machine. It kind of sets the center of balance in kind of a weird place. Especially if you print a tall print and you have all that weight up there, and then your your extruder assembly gets up high on the machine and starts like going back and forth really quick. You can get some rocking that can give you some minor artifacts in your prints. Just because you end up having like, I don't know if you'd really call it backlash, but yeah, the IKEA lac tables. They're probably a good reference for like the approximate dimensions that would fit your printer nicely. Because I want to say we ended up doing about, again, it's pulled completely out of my ass, about 2 feet wide and about 2 feet deep is plenty. But yeah, I don't know. If you have a printer, you can just measure it and just leave yourself, a few inches on either side for clearance. A data cabinet. I don't know what that is. I should get one of those IKEA lac tables. Lac table sounds like my wife is pregnant. And that sounds very similar to something we've had to discuss a lot with the baby coming soon. Lac table. Exterior dimensions 42 by 42 by 38. Yeah, there's just a few things like you have to like especially if you have like cable chains on the heat bed, you need to accommodate the little bit of extra space that hangs out the back when the build plate is the whole way back. Stuff like that. Like you want to think it out a little bit, but I think even those lac tables have enough space inside for that, so it's not too big of an issue. But I think we're all caught up on chat here. It's a server tower. That must be a big ass server tower to be able to fit the printer in. Do you mean like I don't know what you'd call them with the individual like yeah, I'm gonna stop. But I assume you mean a server tower that has like those rack mount units in there, because it's not, because I have like a server tower sort of case for my computer, and it's not anywhere near big enough, even though it's huge for a computer case. That thing's like 10 inches wide, about 30 inches tall, and about 30 inches deep. You never know how big the MK3 would be. We actually discussed that a little bit on the stream. I guess on their blog, they must have talked about it a little bit. Server blades, that's what it is. But yeah, I just reiterate what was said there. Like, I wouldn't be surprised, because I was kind of like speculating what Prusa might do in the future, and then someone said that that's more or less what they had talked about on their blog or whatever. But I wouldn't be surprised if they do a little bit more of a refined machine, like probably enclosed, for companies to buy and not have to worry about like building an enclosure or anything. It's just like enclosed already for printing ABS and some things like that. So I wouldn't at all be surprised if the MK3 looks a little bit more like the self-enclosed printers that are already on the market, which is cool. It'll be cool to see what they do in the future. Given the success of the MK2, they pretty much have the funds to do whatever the hell they want to do. And I wouldn't be surprised if it's a little more appealing to them to cater to like the the professional end of the market as opposed to like the consumer end. I would assume there's a lot more money there, which is always going to influence companies. There's two things. There's going to be more money, and then there's going to be like significantly fewer kind of like idiots like me that are likely to have problems with their printer. If you're selling to like professional establishments, it's more likely that they're going to have someone there that's knowledgeable instead of people just like buying a kit, trying to throw it together, and then running into problems because they did stuff wrong. So wouldn't it all surprise me if they're more looking to get into that market than dealing with consumers? I rem- I remember the wife being lactable when she was pregnant. Yeah, my wife's, I forget exactly how far she is, but she's getting to the point where she's probably going to start leaking soon. I remember that from the first baby. Yeah, you'll have the double enclosure. You'll have the nicest ABS prints anybody's ever seen. Like one, it's hard to tell. It's hard to tell what they do. They might completely abandon like the i3 design, because I know like Bjorn was mentioning there. You know, there's a lot of printers that the heat beds don't actually move except in the z-axis, and everything else is the extruder assembly moving in the x and y axis instead of just in the x-axis. So, uh, yeah, the future in general I think is kind of exciting for 3D printing. It's really hard to speculate accurately about what's going to happen. It could be like a lot of technology where we're basically anticipating like refinements on existing approaches to 3D printing, when it's possible that like a company will come out and just kind of like completely redefine the game with like a new approach. Because there's got to be tons of companies that are experimenting with stuff right now. You can't. That's true, Joseph. You can't really call it the MK3. Who knows? Like with the size that the company is now, they might kind of branch out and have separate like development chains where they might go down that route and develop like the MK3, and at the same time like introduce like a new design of printer that's more for like higher end professional usage. I agree, Earl. It is kind of scary when companies get to this point, because they're like you said, they're at a crossroads, and they can either just like continue that stellar success or make a bad decision or two and really kind of like tank things for a while. Luckily, I would imagine they already could erode the MK2 for a while as far as like a revenue source. And I think with the S coming out and it kind of like reinvigorating and re-exciting people, I think they're gonna that breathe like a bit of life back into that. So the Mark Forge X, yeah, that's kind of cool. I don't know what the price is on that, but I think it's not cheap. I think it's not cheap. If if I'm remembering the same thing. I know one thing. I've started setting some money aside because I'd like to make as big an effort as I could, because I'm like torn between buying more printers. Uh, but I would love to buy a light forge. There's so many things, like I don't talk about it a lot, but I'm to the point now where I make quite a few different things for gaming, and I'm still just kind of like catering to the local market around here for basically like person to person cash transactions. But man, I'd like to have a laser cutter. There is so much stuff you could do, and between the two, like having a 3D printer and a laser cutter slash etcher, there is so much stuff you can make. It's kind of like mind boggling. Like a 3D printer can already be kind of overwhelming with like what you want to spend your time messing with, and yeah, I'd love to get like a laser cutter. Like I like the Light Forge. I've been following that since it basically hit the market. And they're a little expensive, but they're such fantastic machines, and there's like so much you can do with them. And like if any of you are familiar with gaming, there's companies like Gale Force 9 that make tokens and stuff, and basically all they have is a laser cutter. Like they have a massive product line that basically is all made on a single machine. Like I'm sure they have more than one of them now, but yeah, like their whole company just basically runs off of laser cutters and engravers. And they're not a massive company, but they make pretty good money, especially with like the return on investment that you get out of like some of the acrylic parts that you cut. Glowforge, that's right, not Lightforge. The Glowforge, I'm sorry. But it's like that. It's so hard to make decisions because I would love to have an SLA printer too. Like if I'm sure a lot of you follow Angus, and Angus was testing one on stream the other day. He was streaming, and the prints are so sweet out of the SLA printers. Like they're so nice. Like I know it's like a whole nother bag of stuff to deal with, like finishing the prints and whatever you have to do there is quite a bit different than, and it's a bit more work than with like FDM printers. Like we just basically snap stuff off our build plate and it's done. But the surface quality on SLA prints is pretty amazing. It's kind of like we can't even really begin to touch the quality of SLA prints with an FDM printer, which doesn't matter for a lot of things, but some things like the surface finish is everything. So yeah, I'm torn. Like I just want to have all the things. I just want to have everything. I just want to like never leave my basement and play with stuff constantly, because it's all pretty sweet. One can dream, eh? But yeah, because if anybody has a Glowforge or an SLA printer or other 3D FDM printer that they want to send my way, I will gladly receive it and do videos on it. So I'll just put that out there. I'm not asking. Let's make this clear. I'm not asking for it. I'm just saying, if one were to come my way. What am I using under my printer to reduce noise? Actually, nothing at the moment. Really nothing. All I have under there is like a glass cutting board, because my bench in the corner there, where the two, like this side and this side comes, isn't perfectly level. And I just have like a fairly thick glass cutting board under there, which probably does help with the noise a little bit, but yeah, the Formlabs. That's a little out of my price range. That's like almost what my car cost. But yeah, nothing particular. I had looked at Lowe's. Like if you go, it's worth, if you're having issues with noise, I never did measure what the actual base plate is. It looks like it's about 10 inches by about 16 or 18 inches, like the actual footprint where the machine touches the table. Like I was at my local home improvement store. Like it happens to be Lowe's in the little town I live in. It's worth checking there periodically, like in their tile section, because they still have them, I think. And I think the pieces they had were like 10 by 16, which would be perfect. But they actually had marble that must have been left over from like a special order. And I should pick up some of that. Like any dense material. Like I know some people have used like garden pavers, which are a little rough. That's, I don't know, like some people might be fine with something like that in there, but a little dusty and not the prettiest looking thing to have sitting in your little workshop if you're cared about like how it looks or anything. But it's worth checking in periodically, because I think those slabs of marble, which are pretty damn dense, like they're a lot more dense than like some of the ceramic tile and stuff like that. You can get some of that stuff pretty inexpensive if you're just looking to buy like a leftover piece like that. I do have these things that I got somewhere. It's either like the worst idea ever or the best idea ever. They have basically, I think they're called bungs. They're like rubber plugs basically. And I got 4 of them that are, I don't know how big they are. about 25 millimeters on the thick end, and a little less than that, about 20 millimeters on the thin end. And they're kind of soft rubber. And I wanted to experiment with like making feet, like actually printing a little piece that would like cup the feet on the printer, and then have like a round kind of inlet area where you could sort of like epoxy these into the bottom of them, and try these as feet, because I think they would work well on almost any surface, and I think they would be very inexpensive. I think these were like $1.70 a piece. So you're looking at what, maybe $6 or $7, and if you print the little holders that I've yet to design, you're probably looking at like a couple cents worth of filament. So for less than $10, you could really deaden noise. And I don't think that these would have the same rocking problem that like the dampeners, like the printed dampeners have, because they're able to flex a lot better. But yeah, and like if you start, like Bob just mentioned, if you start combining things, the results could be pretty dramatic. Like if you'd have, some rubber feet like this, or some of like someone mentioned like TPU, or you could probably even use like Ninja Flex if you keep it thin so you don't get too much rocking. If you'd have some kind of damper feet and like a really dense slab that's going to absorb like a lot of those lower resonance sounds, you could get it pretty quiet. Talking is hard, but I'm excited about the S kits, and I would assume from what they said that some people already have basically intact S kits that they've been shipping over the last few weeks. So I guess for some of those people, it's hard to tell a difference because they don't have the original linear bearings. But being that some of us, or probably most of us here, have like the original linear bearings that ship with the kit, I'm anxious to see if that does reduce the noise. I would assume the chrome rods are going to reduce noise because they just have a smoother finish. So when the bearings are rolling, there's going to be a little less like noise that they make. Joachim, do you mind dropping us a link? Like, I know you have to like bastardize the link. But yeah, if you wanna drop a link to them, like myself and I'm sure a lot of other people here will check them out. I don't have any TPU, but I think I do have a little bit of the Ninja Flex sample left. Yeah, Scott, but if they're the ones I remember before, they appeared, if it's the damper feet that they've had for basically ever, they seem like solid pieces that just like sit under the rods, and I cannot fathom how that helps with reducing noise. I don't know. I guess it could. I never tested them, so I guess I shouldn't comment. But it just seemed like they're not substantially different from the feet that it's already sitting on. Like I don't know how that absorbs any like vibration at all. But I don't know. To be fair, I haven't ever tested them, so I could just be kind of looking at it the wrong way. I don't know. But has anyone here ever printed them out? Because I remember hearing that they had those, and I went and looked at them. I was like, well, shit, that's not going to do anything. It did help a bit. Yeah, I guess are they just relying on like the kind of sparse infill to kind of not transfer vibration as much? Like I just couldn't understand how they worked, really. It seems to be like still like a solid, physical connection to the surface that it's sitting on. So, but anyway, we're at 3 hours and 20 minutes. We'll quit rambling. I'll be streaming again this week if you guys want to continue a conversation. And maybe one day, like I said, I probably will send Prusa an email and see if they could maybe get me an S kit a little bit sooner so we can talk about it sooner than 6 weeks from now. That would be cool. And if I do, we'll probably do a stream that's dedicated to that, where like almost certainly if I do get the kit, I'll install it on stream, and we'll probably talk about it there. And I'll probably have some tests ready with the decibel meter and stuff to compare like the bearings and stuff. But hopefully we can do that sooner than 6 weeks from now, ideally. But yeah, and don't forget, any of you that weren't here for the stream itself, if you don't mind taking the time, or at the very least, if you get some ideas, you can drop a comment on the stream when it's like up on YouTube later. If anyone has any ideas for some simple little circuits that we could lay out and maybe get a package together on Thingiverse for people to download, because right now it's pretty grim on there. There's a couple like little LED flashlights and stuff, but for the most part, there's really nothing that people can really mess with this conductive filament with for the most part. So if anybody has any ideas, design the file yourself if you want, and drop a link to it in the description or in the comments. Or if you just have an idea and can't be bothered to throw it together yourself, drop a comment and kind of share some ideas you might have to maybe use this stuff to get some kids into 3D printing or something would be cool. But yeah, we're gonna cut it there. 3 hours and 20 minutes. Still not the longest stream, but maybe a stepper driver with it. Yeah, anything, man. If you can come up with like a plausible idea that's worth exploring, maybe we'll do a stream. Like maybe this weekend, if there are a couple comments and I get a chance to stream maybe Saturday or Sunday, maybe we'll jump on and try to throw some really simple circuits together and start working on that this weekend. That would be cool. But yeah, we'll be here. I don't know what it's like usual. I won't know what we're doing until about 24 hours before, probably less than that. But like usual, I'll be streaming Thursday at 10 a.m. Eastern Standard. We're probably going to adjust the time that I stream on one of the days so it works out a little bit better for some people. Like I know, like Angus, for instance, is in Australia, and he sometimes catches the very beginning because like it's pretty late there. So maybe I'll start streaming early one of the days and a little bit later on the other day. Maybe kind of try to make it work for people, but we'll see. Like usual, if you have any comments about that, like stream time, just drop a comment on this video. So anyway, guys, I'm going to quit rambling. Thanks for hanging out with me. Hopefully I'll see some of you Thursday. And until then, I hope everybody has a great day. So later, everybody.